Welcome from the LESER Chatroom, welcome from Hamburg, welcome from our LESER Chatroom, our demonstration facility for overpressure protection with safety valves. Here we can show different demonstration like inlet pressure loss with too high inlet pressure loss leads to the typical shattering. Then we can show here different demonstration. For example, the too high build-up back pressure, what happens then? We see a typical cycling phase there. So we can show here a lot of different demonstration in our LESER Chatroom. But today we want to talk about the topics safety valve solution for the high cleanliness requirements for the pharmaceutical industry. First, if we want to answer this question, what is the right product and what are the right solution from our LESER company, we have to look on the different requirements. What are the three requirements? We define three of them. The first requirement is that we must have efficient cleaning in your plant. And what means efficient cleaning, we will see in some minutes. Then the second requirement is that the safety valve, the clean service safety valve, must fit in your plant. So there we talk about a little bit later about this topic of the second requirement. The third requirement is that the safety valve must design to the latest codes and standards, and that we have the right approvals for the different markets. So these are our three requirements. Let's start with the first requirement. This is the efficient cleaning. Maybe first a short view at your home. If you're cleaning your bathroom at home, you have, for example, in your bathroom different surfaces. For example, the mirror, the shower, and so on. Different surfaces. Then we have edges that are very hard to reach and to clean. And it is useful, for example, to use warm water or some other cleaning products to clean your bathroom at home. If you look now in your plant and we compare these two processes, then it is nearly the same. You have some edges, some pipelines there, for example, and it is very hard to clean. And what is important there? Important is that the process is very efficient. Efficient for you means this process, this cleaning process, must be as short as possible. So, because the cleaning process is a non-profit process. If you have, your main process there is to produce your products. And after you have done this, there is a cleaning process. And the problem there is the cleaning process is a non-profit process. And for this, we must to set up to improve this cleaning process. This means we do it on a short way and an optimal automatic way. So there are different cleaning processes. For example, there is a SIP. SIP means, for example, cleaning in place. This is a full automatically cleaning process, and it is without removing any safety valves. You don't remove the safety valve from the plant. If you have higher requirements, for example, for the pharmaceutical industry, our topic today, there we must improve this cleaning process, and this is the name of ZIP. ZIP means sterilization in place. And this process you do after you do the SIP cleaning process. You do the sterilization in process with steam and on a temperature of 121 degrees. And this process is limited by the rubber materials of the clean service safety valve. a typical standard limit from our side is 150 degrees for a standard rubber material. This is around 4 bar. And these are the limits here. So you hear about something about the zip process. Then we heard about the zip process, sterilization in place. And then the third one is cleaning out of place. This means we, remove the safety valve because there are spaces that are hard to clean. Then we must remove the safety valve and then we can clean it. So this is cleaning out of place. So if we want to have efficient cleaning, there is some word it called dead space ratio. And what dead space ratio means, I will show you in a 3D animation live here in the LESER Chatroom now. So here we see our 3D animation API. This is our type 526. It is a spring-loaded safety valve. It is designed to the standard API 526. The name is American Petroleum Institute here. It stands for the API, the short version here I named before. Yes, and what means dead space ratio now on this API safety valve? If we see the length from the protected system, this is here, up to the disc in the middle of the safety valve, this is the length, and that we set in relation to the inlet diameter from here. So these are the dead space ratio. Okay, I explain it again. It is the length from the protected system to the safety valve disc in relation to the inlet diameter of this safety valve. And what is, I will call it a problem here in a cleaning process with a standard safety valve, we have a high dead space ratio. Here we have a dead space ratio round about 6, so it is very hard to clean if you are starting a cleaning process. And for this safety valve here, if you start, for example, your cleaning process, you need some additional efforts to remove the dirt, to remove the bacteria here. And if we now switch over to our clean service safety valve, there we see LESER designed clean service safety valve type 48X here, and we have a very small dead space ratio. If you look now on the body here, we reduce the length. So it is the length of the protected system again to the disc. And yes, we have a higher inlet diameter here. And so we have in the inlet a very small dead space ratio. It is round about 1.5. So it is a very, you can very start efficient cleaning process here with this clean service safety valve. And if you have a dead space ratio over 1.5, then there is a problem of a dead leg. And what is the meaning of a dead leg? There is a space that is not cleanable automatically. You need additional efforts to clean it. And to show you more what is the meaning of the dead space ratio, this was our 3D animation of API and clean service safety valve. We are going now over to our demonstration here in the LESER Chatroom. So what we see here is, yes, a demonstration, a short demonstration planned. I will show you the cleaning process. First, if you look on the first line here, we have a pipeline with a small dead space ratio. I fill it in here with with some color. So it means the color stands for the bacteria, stands for the dirt here. And if we go next to me here, we see a dead space ratio roundabout of 6. And yes, we can compare it with our demonstration before. We have here our clean surface safety valve with a small dead space ratio up to 1.5. And here we have a dead space ratio of 6. And what I will do now is to flash some water, some cleaning product in your plant through the pipeline. And every flashing process, every cleaning process here runs for 30 seconds, and then we can compare it. And one sentence again, 1.5 we have and 6 of dead space ratio. We have this same inlet diameters here, but we have different lengths. And so it is here 6 and here 1.5. So let's start with our cleaning process of 1.5. I flash now some water through this pipeline. I opened the outlet here, and now I open the inlet, and the process will running now. Now we see there is a cleaning of your plant. The water goes through the line here. 15 seconds left. This was our first run here. So what we see, I will explain a little bit later. And now we are starting directly with the second pipeline in the background. I open the outlet and open the inlet, and we flash some water and have a look what happens in the dead space ratio in the inlet of the safety valve of roundabout 6. I start now the demonstration. Now the cleaning process is running. We see here is a cleaning process. We see the water goes through the pipeline here. 15 seconds left. So this was the second demonstration, and if we now compare the colors, this is typical now for your cleaning process. We are talking about the SIP process and the ZIP process. I told you before what is the meaning here of this process. It is that we have here on the 1.5 a very good cleaning result. You see the dirt is flushed here away, and yes, so we see efficient cleaning of this pipeline. And if we compare it with the color here, we see there in the lower area there is the dead leg. And dead leg, I told you before, is one effect that we need additional efforts to clean now the safety valve. So we must remove this clean surface safety valve or other safety valve, for example, and there is no automatically process behind this, so this is typical and stands for cleaning out of place. So remove it and clean this safety valve here. So this was the meaning of the dead space ratio. One big topic for the efficient cleaning process. dead space ratio, and the second topic there is the different surfaces. So 20 years ago, round about 20 years ago, there was the meaning as smooth as a surface is, as better is the cleaning process. But this is a lie. And why is this a lie? I will show you in the next graph beside me. So, what we see here is on the left side is a very smooth material. It is, for example, comparable with your mirror at home. And what I told you before here is that the bacteria, the dirt, glue on the surface here. So this is a big problem, so it is not good to have a too smooth surface. On the right side, you see a typical cast iron. There we have a rough structure, and the bacteria go in the structure there. And if you now flash through the pipeline, there is no removal of the dirt and of the bacteria here. So this is a problem. And the best surface is between these both areas, both sections. So left to smooth, right to rough, and in the middle there is a perfect surface. And here it is, our clean surface safety valves fulfill these requirements of these special surfaces here. So this is what I want to tell you to the efficient cleaning. So keep in mind, it is important to have a safety valve, a clean surface safety valve with a small dead space ratio to have effective, efficient cleaning process. And it is important to have a good quality of the surface. Too smooth is the wrong way, too rough is the wrong way. This was our first requirement, some information about the efficient cleaning process. Now we want to talk about the second requirement. The second requirement was that the safety valve must fit in your plant. So for this, I have here on my table different clean surface safety valves. 1 second. And then I will show you some examples. What is the important thing if we talk about the safety valve must fit in my plant, and what is important, that it works on this way is that we have, for example, if we are talking about the cleaning process out of place, then it is important that we can clean the body here. What means this? This means that we have here designed a screwed lifting lever. So I can screw on this here, and then I opened the disc, or I remove the disc from the seat, open the safety valve here. And what is important here is that we don't change the set pressure. So now I have removed it, and what goes on next is that we can open here the clamp, and if we open the clamp, then we can remove the whole package here. This means with bonnet, with cap, with spring, with seat. I can remove it, and then we can wash out cleaning the body here. So this is one big example if you have a cleaning out of place. So we call it screwed lifting device here. The next advantage is if you want to have an automatically cleaning process. This means cleaning or zip. This was cleaning in place, and zip sterilization in place. For this we have designed here pneumatic lifting device. Pneumatic lifting device means that we can go over here with pressure air, and we can lift if you have your cleaning process automatically in your plant. We can open the safety valve with pressure air here on the top. What's going on next is here the high tide disc. This is a special design of LESER. If you use O-ring discs, then there is in a normal way in the middle of a normal disc. You see, if you use an O-ring disc, there is a screw with a nut. And here is a design without this screw and without this nut. So it is, yes, a very clean-able design. And all other components here are protected with a rubber material. So if you clean your plant, you can clean the system here too. And then there are special designs. Also, for example, here is the vessel clamp with a very small dead space ratio. We talked about the dead space ratio before. This means we have here a very small length to the disc. What you see here is directly the disc. And we have a larger inlet diameter, and that leads to a dead space ratio of around about 0.3. So this is a very small dead space ratio, and it is easy to clean here with your process. And the last advantage here, this is the next clean service safety valve I will show you. There is the clean service safety valve on the pipeline. You see here, this is your process pipeline from the left and from the right side here. And in the middle, there is your pipeline, and on the top, there is the clean service safety valve. And this leads also to a very, good cleaning, effective cleaning here. Okay, and on the next slide, I will show you this was some advantages if we talk about the different the safety valve must fit in the plant, the second requirement. There are some more information on this clean service tower here. If you see the clean service tower, we must talk about different pipeline descriptions. Pipeline descriptions, there are 3 of pipeline description. For example, the ACHEMA BPE. We have also the ISO 1127. We have the DIN. Sorry, I missed the information. We have some more type of DIN, and there are 3 standard types of pipe descriptions. Then we have look on the clean service tower, 3 different types of connections here. And for example, this one here is the screw connection. Here we see a typical flange connection, and we have also the clamp connection, and these are the 3 standard standard connections to fit in the plant. And the next one is we have 3 standard types of tightness, and so this leads in standard to 27 combinations. So these are a lot of standard combination, 27 in some here. And what is the big advantage of LESER here is that these standard types are available in 2 weeks. So the delivery time are 2 weeks for this standard combination of 27 in some here. And maybe we have a little closer look here. This is what I told you before. This is this one here. And if we have a look, here is your pipeline. The clean service safety valve sits on the top here. And yes, there is a very efficient cleaning process if you use this clean service safety valve in this design here. Okay, and maybe one look again on the top. This was the vessel connection here, and this was the best dead space ratio of round about 0.3. So it is there is a very efficient cleaning possible in your process here. Okay, then we talked about today about different topics. These are the 3 requirements. Maybe a little I sum it up now. So 3 requirements. The first one was efficient cleaning. Keep in mind there was, for example, the zip process, and the cleaning out of place. This leads to different safety valve clean service safety designs. Then we talk about the topic efficient cleaning with a very small dead space ratio. I showed you the dead space ratio on the 3D animation to compare an API safety valve with a design of clean service safety valve. Then there was the demonstration of the dead space ratio, and you see with some different colors that we have a very efficient cleaning process with the small dead space ratio here. Then we talk about the different materials. So the materials also important for the cleaning process. Too smooth is the wrong way, too rough is the wrong way. The middle, the design of LESER, the material we use, this is a good example for the efficient cleaning. And the last part for some seconds was that the safety valve must fit in your plant. And for this, there are special designs. For example, the screwed lifting device and the H8, we called it the pneumatic lifting device. And you see some different combination, and this leads to our advantage 2 weeks delivery time here. So this was our demonstration from the LESER Chatroom here. And yes, if you have any further questions, you can contact us directly on our booth, on our virtual booth on the ACHEMA Pulse site. There you see our different employees, our different staff workers. They are available the whole day for you. There are a team of our product solution team for detailed technical questions. There is our sales. So if you want, you can set up an appointment with them, go on a video call with them and talk maybe about the topic for today with them. Yes, I want to say goodbye from Hamburg. Have a nice day all, and we see us in the next session. Thank you.